So in section 5.3, we're going to be talking about the graphs of the trig functions. Particularly here, we're going to start off with the sine and cosine functions. And so what we're going to be doing here is taking the values of sine and cosine and plotting them like we would the y values for a function. So starting with an x value as an input and putting a y value out as the output. Here, let's start off by looking at the sine function. So we'll graph f of x equals sine x. Now, if you notice on the x-axis, I have here laid out all of the values that we've talked about in the unit circle from 0 all the way up to 2 pi. So I'm kind of working my way around the unit circle. And I'm going to plot the values of the sine that we see within the function. And so let's start out with, again, the sine function. We're looking at the y coordinates of each terminal point on the unit circle. So following with the unit circle, the value of sine starts down at 0, and then it's going to work its way up to 1 once we get up to pi over 2. So as we go through the values for pi over 6, pi over 4, pi over 3, the values are going to slowly grow up till it gets up to 1. And then notice how after we get up to 1 up there at pi over 2, the values are going to start to decline until we get all the way to 0 over at pi. So by the time that the function gets around to pi, it's going to have slowly decreased down back to 0 again. And then as we go through the third quadrant here, notice how the values of the terminal point and the y coordinate go all the way to -1, which means that as it gets down to 3 pi over 2 here at the bottom, it will have traveled slowly downward to -1, kind of like this here. And then as we go through quadrant 4 and get back to 2 pi, the values will travel from -1 back up to 0 again. And so this is what the sine graph will do, traveling between 0 to 2 pi, going up to 1, down to 0, down to -1, and then back up to 0 again. So it makes a complete cycle. One cycle of the graph, we call that one period. And we say that the sine function is periodic. Because the values will go through a cycle and then go back around again and keep completing that cycle over and over again. And one period of the sine is equal to 2 pi, which makes sense because that's how far it takes us to get around the unit circle. The height that we go up to and the distance we go down to the bottom, how far away from the middle the graph goes, is called the amplitude. And the amplitude, as we can see here, would be 1. Because the graph goes up to 1 and down to -1. So those are the words that we use here for sine functions and also for cosine functions: period and amplitude. The graph will continue to do this over and over again. If we were to go to the left, we'd see the graph go through the same exact cycle. And we can keep going to both left and right, and this graph will continue to do the same thing over and over again. As it goes through one period, it travels through the same values over again. Now we're going to look at the graph of f of x equals cosine of x. So when we look at the values of cosine, those were determined by the terminal points with the x-coordinates. So let's follow the x-coordinates as they change in the unit circle. The difference on the cosine here is if we look at the first number, it starts at 1. So the first point I plot here is up here at 1 for the cosine. Then it goes down to 0 at the next coordinate up at pi over 2. So what will happen to the cosine is it will slowly decrease in value till it gets to 0. And then from there, as we go through quadrant 2 and get down to pi, once we get to pi, the value of cosine will have gone all the way to -1. So over here at pi, it will have declined slowly downward to -1. And then as we go through the third quadrant, notice how it gets back up to 0 at 3 pi over 2. So the graph will slowly curve its way back up to there at 3 pi over 2. And then at 2 pi, it will have made the complete cycle and made it back up to 1 again. So it looks something like this. So this would be what we call 1 period of cosine, which is still equal to 2 pi, same as it was with the sine function. We still have the amplitude, which tells us how far up and down this thing is going. So the amplitude is still 1 in this case. The only real difference is where we start the function out at. This one starts at 1, where the sine function started at 0 instead. So if we follow the other direction, it'll do the same thing. It'll curve down to -1, then back up to 1. Now, when discussing the graphs of sine and cosine, they can be transformed and shifted just like any other graph can be. But we have special names for some different kind of transformations here. I mentioned the amplitude. The amplitude can be changed by stretching it up or shrinking it downward from top and bottom. We also can have changes in period. Changes in period will be when it gets shrunk by side to side or stretched outward to the left and to the right. And then there's another one called phase shift. Okay, phase shift is left or right shifting. So they just give it a special name for that kind of horizontal shifting to the left or to the right. So here's some illustrations of changes in amplitude, period, and phase shift. And so we can see the amplitude shifting here. It can either get shrunk or it can get stretched. And the thing that's going to determine whether or not it gets stretched or shrunk is the number that goes out in front. So for instance, if we had 2 sine x, that's actually going to make the amplitude bigger and make it stretch up and down. On the other hand, if we had y equals 1/2 sine x, that's going to shrink it by making it smaller from the top and bottom. And in the period, the difference will be what number we put inside next to the x. So for instance, if we put y equals sine 2x, our graph is actually going to get smaller in period, get shrunk as a result. On the other hand, if we were to put a function like y equals sine of 1/2 x, it actually causes it to get stretched. The period will actually get larger as a result. So depending on those numbers, we can have different kinds of stretch or shrink, causing the period to get bigger or to get smaller. And we'll look at some of those examples. And then lastly, down here, the phase shift is when, again, it gets shifted to the left or to the right. And so that's just an illustration of what happens in the graph when we see left or right shifting. So this all can kind of be summarized like such. If we have a function y equals a sine k x minus b, or y equals a cosine k x minus b, what we're going to have here is some numbers for a, k, and b if they show up in the function. The a will determine the amplitude. They say absolute value of a equals amplitude here. 2 pi over k is going to determine the period. B is going to determine the phase shift. And then there's another thing we'll talk about later called the increment, which is 1/4 of the period. This is going to help us when we go to graph the functions. So I have the steps here to graph. I'll let y'all look at it if you'd like to, but I'll show it in some examples here in a few moments. Before we jump into graphing anything, let's see what we can do just to find the period, amplitude, and any phase shift for a particular function. Okay, and once we figure that information out, it's going to help us when we go to sketch the graph of the function itself. So let's look at the function y equals -2 sine of 1/4 x. Okay, we need to figure out the amplitude, period, and phase shift. Start off with the amplitude. First off, though, let's identify the letters for each of these things here. That one out in front, that's going to be referred to as a. So a is -2 in this case. That number we see inside, which is multiplying times x, that's going to be the k. So that'll be 1/4. When we talk about the amplitude is the absolute value of a, or the absolute value of -2, or just +2. So whatever if it's a negative number, it'll be a positive here for amplitude. The period we calculate by doing 2 pi divided by k. That here is going to be 2 pi divided by 1 divided by 4. When we divide by a fraction, we multiply by its reciprocal. So that will look like 2 pi over 1 times 4 over 1, which would equal to 8 pi over 1, or just 8 pi. Now in this situation, there's no number for b, so what we're going to get here is no phase shift. For this next one, we have y equals 3/4 cosine of 2x plus 2 pi over 3. Now remember that the basic form of these functions should look like a cosine k parentheses x minus b. It's what I had mentioned up above in the situation that showed what a, k, and b were referring to. But the difference by what we're looking at here to start off, and this particular thing with the a, k, and the b, is where the k is located. Notice the k is in front of the parentheses. But in our case, there's a 2 inside but not in front of the parentheses. So what I'm going to do first is I'm going to take a 2 and I'm going to factor out the 2. Okay. Now when I factor out the 2, it's going to affect everything inside the parentheses here. And in order to know what that 2 pi over 3, what's going to happen to it, I'm going to multiply by the reciprocal of 2. Whatever I'm factoring out is going to get multiplied by the reciprocal of 2, which is 1/2. So I take 1/2 times 2 pi over 3, which turns it into 2 pi over 6, which turns it into pi over 3. So when I'm done here, I'll have y is equal to 3 over 4 cosine of 2, and then in parentheses, x plus pi over 3. Okay, now we can say what the a, k, and b are going to be equal to here. A is the number again in front, so that's the 3 over 4. K is going to be equal to the 2 in front of the parentheses. Now determine what b is equal to. Let's do something here with this stuff. Let's take what's in the parentheses, set that equal to 0. Let's minus over the pi over 3. So that it changes into x is equal to negative pi over 3. That's going to be the number that we can use for b. b is equal to negative pi over 3. Okay, so now we know the three numbers. We can say what the amplitude is to start. Amplitude is 3/4. It's the a value, 3/4. It's a positive number here. The period is 2 pi over k. So that's going to look like 2 pi over 2, which is just going to equal 2 pi. And then the phase shift, which here I'm just going to abbreviate that PS for phase shift, is going to be the negative pi over 3, which in terms of the graph means that it's going to be shifted left by pi over 3.